This podcast is an introduction into writing formulas and writing the names of compounds. So for our chapter 7 in our text, that topic today, we will only focus on one thing, and that is ionic compounds here. Naming ionic compounds, but we will not do covalently bonded molecules, and we won't do any calculations this morning. So, again, ionic compounds are compounds that are formed between two ions. Those ions have to be oppositely charged, and in general, those substances are either a metal or a nonmetal. They come together to form positive and negative ions, and so those charges must balance each other out. So again, an ionic compound in general comes from a metal ion and a nonmetal ion, and those ion charges have to balance each other out. So sometimes you need more than one of a particular ion in order for them to balance out, and so that concept of least common multiple would be used. When we write the formula or when we write the name, we always put the positive ion first, sort of like in life. You want to put the positive first. So you've been doing flashcards with the charges of ions, and perhaps if you haven't already done so, line up all of the elements that are found in the first column of the periodic table and notice their charge. And then do so with the second column, the second to the last column, and the third to the last column. You might pause the podcast, do that, organize your elements, and notice a trend in the charge and also the name of these ions. See what you discover. First of all, did you notice that metals are on the left side and they tended to form positive ions, and those things that are on the right-hand side of the periodic table form negative ions? And of course, noble gases, they don't form ions at all. Their charge is 0. Did you see this lineup, that the positive ions are found in the first column, highlighted in pink here, and the positive 2 ions are highlighted in yellow, and then we have 0 for the noble gases, but then -1 and then -2 for those non-metals. Also, I would call attention to 3 ions in particular that also always are the same. I've put the symbols of those up here. Notice that they go diagonally down the periodic table. +3, +2, +1. Aluminum is always +3, zinc +2, silver is always +1. Other metals, when they form positive ions, can form a variety of charges. Copper is one example. Copper can form +1 and +2 ions. How do we distinguish between these two? We use a Roman numeral. The Roman numeral tells you the charge on the positive ion. We don't need to memorize those charges, but we might need to figure them out when we look at the formula, or if we look at the name tells us the charge on the metal ion. So this is a little review. Take a few minutes to think about, using only the periodic table, what you have to complete the table. Go ahead and make this table in your homework. Fill in the table, pause the podcast, and then at the next slide, check your answers, correcting as you go with a different colored pen. How did you do? This is the correcting page, so hopefully you've finished. And again, the names of the metals versus the non-metal ions. Did you notice that the metals, the names is the same as the element, but the non-metal ions, fluoride, oxide, bromide, the ending is IDE. That attention to detail is what we'll need when we name compounds moving forward. Can you complete this table? Notice the pattern. Remember that I said that the name of this ion, we have to show the charge by using a Roman numeral. Okay? So pause, complete the table, and then when you go to the next slide, you may need to pause again to check your mistakes. Again, check your mistakes. How did you do before moving on to the next slide? Go ahead and pause it if you need to. Okay, a couple other things just to review. Monatomic, of course, means one atom ions. Here are 3 different examples: sodium, zinc, oxide, and bromide ions. They have a variety of charges. What's different is these type of ions called polyatomic ions. Polyatomic ions are kind of strange in that there are 2 or more atoms bonded together and they carry a single charge. So the nitrate ion, the whole nitrate ion, is NO3, and it carries a charge of only -1. It's not -3. It's not -3 because of this 3. It's -1. Likewise, the sulfate ion is SO4, and it carries a charge of -2. And the ammonium ion carries a charge of +1. The ammonium ion, I believe, is the only positive polyatomic ion that I've asked you to memorize. So next we're going to put it all together. In order to put it all together, we've got to combine a positive and a negative ion and put them together in the right proportion so that the compound is neutral. The compound the charges add up to 0. So here's an example. Lithium ion, what is its charge? It's +1. Chloride ion, -1. Oh, the charges are equal. I only need one of each. So I have LiCl, no subscripts, but notice this. There are no charges shown when we write the formulas. Common mistake, girls, so please remember, no ions shown when writing the formula of a compound. Let's do another example. Lithium oxide. This time the same lithium ion, but the negative ion is actually -2. In order for these 2 charges to balance out, I end up needing 2 lithium ions to balance out the -2 charge of the oxide ions. Notice that the total charge cancel each other out. We write the formula Li2O because we use 2 lithium ions to balance the -2 charge on the oxide. Here's the formula and the name. Another example again, barium bromide, +2, -1. Barium bromide, the name, the barium ion, the bromide ion. We put those 2 names together to name the compound, and then we have to use 2 bromide ions to balance out the barium charge to get the formula of barium bromide. Again, another example. Notice that these charges are the same. We only need one of each, zinc sulfide. Now notice, copper and fluoride ion, here the copper ion is +2. The name of that ion is copper Roman numeral 2. The name of this ion, the fluoride ion, is fluoride. When we put these 2 together, we need 2 fluoride ions, so we have the formula CuF2. If we apply that same thing to a different copper ion, one that is only +1, notice that we have a different formula. So if you compare the 2 equations, or excuse me, the 2 formulas, you see copper fluoride and copper fluoride. But notice the difference. Copper 1 fluoride has 1 copper and 1 fluorine. Copper 2 fluoride has still 1 copper, but 2 fluorines. A few more examples to show you again. I'm going to scroll through a few of these just to see how you do and get through to the place where you can see where I'm going to have you practice. All right, so here you go. Here's your practice. You're going to pause the slide. You're going to come up with the formula and then name the compound. Be attentive to Roman numerals. be attentive to making sure that the charged balance, and write these down on your homework paper. Once you finish, go to the next slide, and if there are corrections to be made, re-pause the podcast. There's the formulas. There's the names. Did you forget formulas? Did you forget subscripts? Here's a good example of a tricky one. Since aluminum is +3 and oxide is -2, the least common multiple of 3 and 2 is 6. What does that mean? I need 2 aluminums and 3 oxides. Thus the name. Why don't some of these have Roman numerals in the name? Because they are always silver, calcium, and aluminum. Always have a fixed charge. They don't have a variety of charges, so no Roman numerals are needed. All right, now, here's the hardest part, and then your homework will end. So, in this last part of the podcast, you are going to try to write the formula of the compound, and notice I've got the names already written for you. The formula with polyatomic ions. Notice I have 2 hints there. So silver nitrate, the nitrate ion itself only has a -1 charge. Second hint, this is the tricky part. If you need to use more than 1 polyatomic ion, put parentheses around it, and then after the parentheses, use a subscript to indicate how many polyatomic ions you used. Okay? I'm not going to give you the answer to these, so in order to find that out, you'll bring this to class tomorrow. Have a good night.